We talked about feedbacks in the Earth system when we were looking at past climate changes, and in this modern climate change we haven't mentioned it much. So, I will go through a couple of examples of potential feedbacks. It is not always easy to extract the feedbacks, but there are many examples where interlinks become rather obvious. So, let us look at some cascading impacts which are essentially perturbing one system and see how that perturbation propagates through to other components of the Earth system. Feedback essentially means how then the responses come back to the original perturbation. So, let us look at the cryosphere, ocean and forests. So, cryosphere is the component of the Earth system where it is all frozen water. So, glaciers, ice, snow, sea ice, mountain glaciers and so on. And this is just briefly providing some putative feedbacks or theoretical cascades rather than feedbacks on various continents. So, if you have land surface warming with increased fossil fuel burning and increased greenhouse gases, we have already seen that there is definitely land warming happening. That would immediately reduce the spring snowpack, and as we saw, that can increase the variability of the spring melt off in the river runoff, and that obviously would lead to early spring peak flow in the rivers that rely on mountain snow melt, which is very common at high latitudes. It would also cause glacier to shrink, and the impacts can be high or very high. Very high, high means it is somewhere in the range of high and very high. Permafrost degradation we talked about. Those things can feed back to changes in river discharge and then ecosystem responses that I mentioned. This is increased runoff in glacier fed rivers. We also have ocean surface warming and atmospheric warming, and the winds are changing. Ocean circulation is obviously changing as well. So, that would lead to changes in sea ice, and all of them again would lead to changes in thermocast, which we did not talk about, but there will be a separate module for it. It is basically the layering in the lakes that is found. Increased coastal erosion. So, if you have increased runoff, for example, you can have increased erosion, especially when combined with other human activities like removal of mangroves or building on coastlines close to the water, changing vegetation on land, which would slow down the runoff and so on. And you would have effects on non-migratory marine animals, those that live near the coast as in the estuaries and so on, which cannot move away, like crabs, shrimps, oysters, and many effects are well recorded in this sense. And it would affect the impacts of livelihoods of many indigenous people. There are people who live in Sundarbans, hunt and fish, and have other kinds of livelihoods. So, feedback essentially would mean that the impacted livelihood would then come back and affect climate, or in the case of Inuits and so on, it could be affecting the cryosphere and the land surface warming and so on. Cascades are just when we are tracking perturbations through the system. Feedbacks are when we come back and look at how the original perturbation is changed by the cascades, by various components. So, that is kind of not very quantitative, but there are many examples of quantitative cascades that you can find by various sources that will be provided. So, in the ocean we have physical impacts, biological impacts, and impacts on managed systems like coastlines or fisheries and so on, or transportation, shipping, etc. So, surface ocean warming would increase the thermal stratification. What does that mean? If you remember, we said the typical vertical profile in the ocean in low latitudes would look like this. In the mid latitude, the stratification is weaker. At high latitudes, it is basically no stratification. So, when you warm the surface, this would get steeper. So, the gradient would get steeper no matter where you are. That is called stronger stratification. Why is it important? Because for the same amount of energy, mixing colder waters to the surface or upwelling will be harder. There is a slight difference in the upwelling and mixing, which we did not talk about much, but upwelling pulls the water closer to the surface, and mixing then crosses that gradient and puts it into the surface water and makes the surface colder. So, if that happens, then the nutrient, if stratification gets stronger because of the warming, mixing nutrients and carbon dioxide will be harder, for example. That would reduce the photosynthesis and so on. So, some other species may respond, and there are biological details there. I will show this more in detail in a minute. Expansion of hypoxic zones. We will see what is hypoxia, anoxia, and so on. There are plenty of evidences that this is already happening. I showed shift per decade, kilometers per decade already, and so the range of fish and micro and macro algae, it's already happening, and that would again affect larger fish that we like to catch and eat, and that would result in fishery yields like crop yield. We have fishery yield where in a given region, if a ship goes and puts the nets, how much fish in terms of tonnage per effort would be in a natural circumstance versus how it is being changed by human activities. There are others like ocean warming also affects atmospheric circulation changes that would affect the circulation of air over the Arctic ice. If it is very high, obviously Arctic ice is already seeing lots of significant retreat since the 1970s. So, that is already there. Corals, mortality, and bleaching we already talked about. The term bleaching we have not defined explicitly, but essentially corals are white calcium carbonate structures, but corals are like the rainforests of the ocean. Once coral structure is built, lots of algae called zooxanthellae and so on get attached to them, and they give the corals the color. And there is a symbiotic relation because the corals breathe and produce carbon dioxide. The photosynthetic organisms take up that carbon dioxide and produce oxygen for the corals, and then other fish come in and live on the phytoplankton. So, you have a whole biodiversity growing around corals. So, if you look at any picture of coral, it is always very colorful, lots of tropical colorful fish and so on. So, bleaching is when the warmth or sea level change or salinity changes will kill the photosynthetic symbiotic algae. So, the color goes away and then the coral becomes more white. This is what we call bleaching. So, obviously, if bleaching persists, then the coral will die because that symbiotic relation is destroyed. So, that is a quick introduction, but you can look it up in detail further. So, those are kind of the cascades. Again, the feedbacks are that if the fishery yield changes, then humans are going to go and try to do things like aquaculture, which affects the coastal water quality and circulation and so on. So, there is potentials for feedback in all sorts of ways. In the forests, another example, atmospheric warming is very important and precipitation changes are very important. So, they would create upward shift of tree lines. So, if you have a mountain and if the colder temperatures are retreating, then warmer species are going to move up. The critical thing there to remember is, as we said before, ecosystems do not move, individual species move. The so called sedentary specialists or mobile generalists, the species that are more mobile and able to quickly adapt to newer regions because of temperature being favorable or precipitation being favorable, they will move, but the original ecosystem as a whole does not necessarily move. The sad impacts or bad impacts, of course, is any warming supports more microbes and more insects. We call them pests basically because they are just trying to survive, but they are bad for the vegetation or the crops that we are worried about and so on and so forth. So, they would increase the tree mortality in the forest, but it also has impact on agriculture as well. So, the soil moisture and drought will be affected. So, typically if warming happens, if rainfall is reduced by 10%, soil moisture might decrease by much larger amount because warmer temperatures will begin to evaporate more of the water. So, the desiccation of the soil will be faster. So, the drought will be exacerbated. So, the so called meteorological drought, which is the rain deficiency, will be amplified into ecological drought or agricultural drought and so on, because of increased evaporation because of the warming. So, that would reduce the tree density, and reduced tree density would have a feedback to the original warming, because that would change the albedo, for example, change the local evaporation, evapotranspiration, local microclimate and so on. So, the arrows here have a symbol. So, there is a major role and minor role, which I did not explicitly say, but here you can see that many things have minor roles and many things have major roles. So, precipitation has one of the most direct impact on vegetation. All plants, like humans, depend on water very heavily. What is happening in the ocean? So, the idea of hypoxia and anoxia we did not explicitly introduce thus far, but I think you are probably already aware of what it is. So, water, we looked at the profile of oxygen, we said it is high near the surface, oxygen minimum zone, and increases again as we go deeper because of the thermohaline circulation. And there are regions of the world where oxygen tends to be low. So, what is hypoxia and what is anoxia? Essentially, when you have values of oxygen something like 5 milliliters per liter, that is called hypoxia, because many animals cannot live in it. Those who can move will move, and those who cannot may suffer greatly in terms of reproduction, growth rates, etc., fertility rates, etc. So, anoxia on the other hand is when the values drop below 2 milliliter per liter, where lots of fish begin to die. And this happens seasonally as well, because when there is strong upwelling, remember that low oxygen water will come up, because you have oxygen decreasing with depth. So, off the coast of Africa here, of Namibia, and off the Arabian western coast of India, there is a natural pool of low oxygen waters. There are additional reactions involved. There are different things live in low oxygen water, because they can derive their oxygen by splitting nitrate into nitrite and so on. We will not get into the details, but essentially then the regions where ocean circulation itself produces low oxygen, and regions where human activity is producing hypoxia and anoxia. How does that happen? Human activity, for example, fertilizing the farms or lawns, etc., when it rains, that is getting washed into the coastal regions. Or you could be deforesting, in which case the runoff is increasing. So, the amount of nitrogen and phosphorus and so on that get washed with the rivers is going to increase. When that happens, there is something called eutrophication, which means the amount of nutrients are excess. So, the phytoplankton will respond very strongly, and when that happens, there is a big bloom of phytoplankton. That phytoplankton is not immediately eaten. So, as soon as there is any phytoplankton growing, zooplankton come along, because they graze on the phytoplankton. The zooplankton are eaten by the small fish are eaten by the big fish and so on. But the zooplankton do not respond immediately, it takes them time. Anything bigger is going to take time. So, that means the phytoplankton, which only typically live for a few days, will die and drop down. When they drop down, there are microbes, aerobic microbes, which begin to eat the dead phytoplankton, like any thing that rots when it falls to the ground or when you put into the garbage can and so on. That consumes oxygen and produces carbon dioxide. So, when these huge eutrophication events happen because of human activities and produce blooms, and they die and oxygen is consumed, you produce hypoxic or anoxic regions. So, directly because of wind changes and circulation changes and the warming, which we will see when we come to the monsoon, hypoxia and anoxia are expanding. And because of human activities and increased coastal settlements, 50% of the people live within 50 miles of the coast, and this number is going up year by year, and obviously it is very attractive to live near the water and so on. So, these effects are already very clear, and you can see some of the evidences collected by this very nice paper, which shows human footprints in hypoxic systems all around the world, and the measure of how much impact there is. Some regions where the impact is almost 100%, it is very clearly seen. So, you can see that essentially all coastal regions all over the world, India is increasingly getting more coastal population, because as economy grows, middle class grows, many people live in nicer neighborhoods and so on. So, everywhere there is a very clear fingerprint of human impact on hypoxia. How does that change productivity? Upwelling changes, winds change, stratification gets stronger, productivity drops because mixing nutrient rich waters into the surface is harder and so on. So, this is the basic productivity we looked at before from satellite upwelling systems like here, but this also has rivers. For example, here is the Amazon river, Congo, Zaire, and our region has lots of rivers here and so on. Nonetheless, we know that the ocean gyres where the currents are converging and water is going down, nutrients do not come up. So, there is some productivity below the surface which we will not discuss, but with the warming and stratification, these low productivity regions are expanding. So, that is kind of consistent with what the Hadley cell is doing in the atmosphere and expanding the deserts, and how the stratification is changing because of the surface warming and how the nutrient mixing is changing and so on. So, there are impacts on land which is shown here. So, this is the global change in productivity on land. Wherever there are these colors, there are decreases or slight decreases. Of course, there are also regions where increases have happened, because as we said, when temperature increases and precipitation increases during a certain time when photosynthesis is still possible to increase, you will get some positive response, especially if you are also having a growing length of season and so on. So, there are some regions where some increase is seen, but obviously you have to be careful, because Amazon also has huge logging and deforestation going on, which is showing up in climate impacts as well. But generally you can see that there are large regions where there is significant drop in primary production on land. So, both in ocean and on land. So, that is different than what is happening in terms of expanding Hadley cell and the deserts themselves. So, where Hadley cell is not having an impact, you are also having human impact directly on either human appropriation of primary production or degrading because of changes in temperature and precipitation. How are the net change in forest area looking? If you look at the last several decades, there are net gains in several regions. Surprisingly, or maybe fortunately, India shows up. It turns out that India, especially more recently, has had tremendous reforestation efforts. China has done similar things. Basically, they were motivated to do that to reduce their carbon footprint, but there is also other issues involved, but we will not go into the details. But you can see that there are regions where massive. So, here even though primary production is increasing according to this chart, net forest area is decreasing, okay? Significant losses, and here primary production is decreasing and forest area is decreasing, and that often has something to do with what kind of conflicts may be going on in addition to changes in climate and so on and so forth. So, complicated picture, but the main point is that the impacts are everywhere. We cannot simply ignore them anymore. Let us quickly look at impact of climate change on health. This is a very vast topic, lots of very nice reports and so on available even for India, which we will look at when we talk about specifically climate impacts over India. But here we will quickly touch upon how the climate change manifests in temperature change, weather extremes. So, more floods for example, like it is happening in India every year now, or more droughts, which is also happening in parts of India. Sea level changes, which means more inundation of water, salinization of groundwater and so on, increasing CO2 levels, pollution. Many kids in India now have asthmatic incidences. So, asthma in kids may be increasing. So, air pollution more directly here, asthma and cardiovascular diseases, and recently there is a report showing that even diabetes is affected by air pollution, and you know that India is a capital of diabetes in the world along with China. So, these are direct impacts, but indirect impacts include changes in precipitation or excessive flood waters staying around and increasing mosquito populations, which are typically referred to as vectors because they move the viruses and bacteria. So, things like malaria, dengue, encephalitis, hantavirus, all your favorite diseases are here, maybe other than dengue. So, increasing allergens, these are basically things like pollens or other chemicals which often are sticking to the other types of pollution. Many people are allergic to pollen and hay fever and so on, that spring allergies etc. are all in here. Growing season length increases, many people are experiencing expanded allergy seasons for example, and there is always a interaction between asthma, temperature, humidity and pollution. Bad news for those people who are asthmatic. Water quality, because of human interactions with the coastal and aquaculture and more nutrients into the water and so on. So, both coastal waters and groundwaters and surface waters over land are being impacted. So, we are increasing things like cholera, cryptosporidiosis, campylobacter, leptospirosis, harmful algal blooms, which is a very broad term often referred to as HABs. These are algae that grow when there is eutrophication or increased nutrients. So, they are harmful in the sense they produce neurotoxins or hepatotoxins, the things that can create temporary amnesia like diatoms called pseudonychia. If you remember Hitchcock's movie Birds, where birds were attacking people, this was based on a true story in San Diego where there was a harmful algal bloom of pseudonychia which produces something called domoic acid. When the shellfishes eat the pseudonychia, they collect the domoic acid because one filter feeder like clam can filter a lot of water and concentrate the toxins in the water. When a bird eats it, the bird is getting an amplified signal of the toxin, and then the birds were going crazy because of that toxin and they were attacking people, kind of when rabies happens, dogs attack people and so on. So, harmful algal blooms, there are many varieties. We should focus more specifically on what is there in your region or in the waters near you and so on. Data is very hard to find, but there is some data. Water and food supply impact, malnutrition and diarrheal diseases, again not directly related, but cascades of global warming through the system. Environmental degradation in general, desertification or conflicts over water and so on. There is very clear evidence now that hot temperatures increase violence and they also have mental impacts, people have depression and so on. And extreme heat, India has become very endemic in its heat waves during March, April, May before the monsoon season. Temperatures are getting warmer and there is evidence that monsoon is arriving a little bit later, as we will see in the monsoon lecture. So, you have heat related illnesses and death. India loses many people every year and there are cardiovascular failures and so on. And severe weathers have also mental health effects and so on and so forth. As I said, very vast topic, and there is data to show that increased temperatures and precipitation and sea levels and pollution are definitely having an impact. This is some work I myself did, where I argued that climate change, other people have done similar work, is going to manifest itself in regional weather changes like heat waves, extreme weather, temperature and so on, which is going to influence which microbes will grow faster or more, how people move in response, and how the vectors change, how the transmission dynamics changes, how the agriculture and water use change, and how that affects mosquito population, and how you are protected from these either mosquitoes or asthma. For example, if it is a heat wave and you get a warning from the India Meteorology Department, if you are well off, you might go into the apartment, close the windows and turn on the AC, but if you are not, what are you going to do? Especially if you are poor and you have to work outside, that will affect your health. So, all global warming in that sense is local. Global warming is global temperature change, global sea level change, but how the temperature, precipitation and pollution, other things change in your neighborhood is going to affect you. And human beings always respond. When there is chikungunya, people may clean up more, or there is people being given vaccines or antibiotics and so on. So, the eventual health outcome depends on how we go from the climate change impacts on various factors to microbes, how they select themselves based on the conditions, and what we do in response, and how that ends up making people sick and who gets sick, old, young, rich, poor and so on. Okay. I want to go back to carbon a little bit, because we want to look again at carbon. We looked at it as increasing since industrial revolution, greenhouse forcing and so on, but the feedbacks from the humans is also beginning to already show up in the carbon dynamics, which we will revisit, not all negative, but we will see what are the main factors that are playing a role in this. So, we kind of finished the main climate change impacts in the modern era since industrial revolution. We will revisit carbon and then conclude this chapter. So, we are essentially changing the trajectory of carbon. Obviously, if you look at the emissions over 2007 to 2016, just as an example, there are many countries where the emissions are actually decreasing, but they represent a huge fraction of the global emissions, and they are other players who are becoming more dominant like China, India, Brazil and so on, but still they are a small fraction. And we will see that as economies develop, everybody has to make a choice, the choice of energy, choice on population, choice on what they manufacture, how they deal with pollution and so on and so forth. But essentially you can see that the Brazil emissions are here, for example, declining, but that may be purely related to the fact that since the oil prices dropped, Brazil's oil income has dropped. So, economy is suffering. This is something we have to always watch, because every time there is a financial crisis, there is a small dip in carbon emission, but then it kicks up again when economies begin to kick up. India is growing fast, so emissions are increasing. China had declined emissions for few years, but now they are moving up again, often related to changes from coal and petroleum to natural gas, for example, which emits much less and so on. So, emissions from Japan have declined recently, but this is all kind of not a trend that we can infer yet, because these are short term changes. So, if you look at the CO2 emissions per year, you can see that the 2016 was up here, a total of 15 gigatons of carbon per year, and China was contributing more in the recent years. USA has kind of remained or dropped, as I said, because of switching to natural gas. India is increasing, but still a small fraction of the global emissions, but that then depends on what you think about pollution. India is now becoming rapidly one of the most polluted, especially if you go to big cities. So, it is not just growing and worrying about carbon emissions, but it is also about how health impacts are, because in a country like US, asthma morbidity costs about $30 billion per year. What are the costs of labor lost or people not able to work because of asthma and so on? We have to worry about those sorts of things when we begin to worry about emissions versus other impacts like health. Okay? By economic sectors, this is useful because when we come back to future climate change and what we can do about it, we will try to see what are the specific actions that are possible sector by sector to reduce carbon emissions. So, just for that purpose, we will take a quick look that electricity and heat production is a big chunk of the total emission. This is agriculture, forest and other land use, that is a massive fraction, 24%. Buildings in India, cooling the buildings in big cities is a big thing, air conditioning is a serious polluter. Transport, again big contributor. Industries as big as power production and so on, and you can see that within the electricity and heat production there is consumption by various other same categories. So, this is important because we have some indirect CO2 emissions here and some direct greenhouse gas emissions. Nonetheless, if you want to plan to reduce your emissions like India's commitment to the Paris Agreement, and we will come to how countries have committed to reducing their emissions, knowing where your emissions are coming from is going to be obviously critical to play on it. So, this is now showing the change in the annual CO2 emission from 1970s and 80s to the last decade, and this is showing various carbon intensities. So, intensity of energy, intensity of GDP and GDP per capita. So, as GDP per capita, so you have, those are the three things you have to worry about. How large is your GDP and how carbon intensive is, or how energy intensive is your GDP, and then you have to look at your energy production and say how carbon intensive is your energy production, because you can do renewables or hydroelectric, nuclear and so on and so forth, right. So, that combination again it helps you to look at your GDP, its energy intensity, and see if you can reduce the energy intensity of the GDP and carbon intensity of the energy, and you can then track systematically how to reduce your emissions. But this is essentially showing that the world is seeing an increase in per capita GDP, obviously very lopsided. Maybe China, India and so on are having a substantial increase, but even in these countries, what is the fraction of population that is experiencing increased GDP per capita versus the larger population? Those are complicated issues. Nonetheless, you can see that the energy intensity of the GDP and carbon intensity of the energy are kind of varying in time. Fortunately, they are not increasing tremendously over these few decades, which is good news. So, all the discussion about climate change has made everybody sensitive to carbon emissions, and that is always a good thing. So, this is just showing, again we looked at it before, that the rate of increase of carbon dioxide emissions is increasing. So, we are now at something like 35 to 50 gigatons of carbon per year if you include land use change and so on, but nonetheless everything is increasing. So, that is something to keep in mind. What are the good news stories? If you look at cumulative installed renewable power generation in terms of wind, bioenergy, solar, geothermal and so on, there is definitely an increase, but most of the increase comes from hydro, which is basically building dams using water to turn the turbines. That is not really a renewable, even though there are multiple ways of doing hydropower. Some are less carbon intensive than others and so on. The good news of course is that the wind has increased tremendously, solar is increasing and so is bioenergy. You have to be careful for bioenergy because, as I mentioned in the case of forest fires in Indonesia during El Nino, bioenergy, things like corn and palm oil are competing with food supply. So, when there is a drought or when there is a forest fire and trying to convert it to palm plantation instead of forest, all kinds of human conflicts and food security issues are involved. So, bioenergy is still kind of complicated story that we have to be careful about. Solar energy, mostly it is a question of efficiency and at what point it becomes carbon neutral. When you produce it and start using it, it obviously will have some carbon footprint, but over time, since it is renewable energy, its carbon footprint should begin to go down. Prices are dropping, installations are increasing and so on and so forth. But if you look at general capacity estimates of renewable energies, you can see a country like India has watts per capita of 0 to 10, some countries have higher, some places have much higher. Obviously, not many people live there, not many people live here either, plus in the middle there is a big desert, everybody lives on the coasts and so on and so forth. Good news for a country like Japan, because it has to import almost everything, and they relied a lot on nuclear, but we will come back and see, as it happened during the Fukushima, there was an earthquake which caused a tsunami. The tsunami damaged the nuclear plant led to radiation, and that made them take a step back about how much they will rely on nuclear and abandon their climate commitments for some time. So, you can have these kind of cascades that always play into the story. So, I will show another story when we talk about future climate change, about how the choices we make are often affected by the politics, the economics, the demands of economic growth, food security and so on and so forth. This is the traffic problems in India. I think you are all aware of it. The news is that China and India are here, but as GDP per capita increases, the vehicle ownership per 1000 persons increases. So, you know that India and China are headed this way. More and more people are buying vehicles in both countries, and if you go to place like Bangalore, you can count how many lakhs of vehicles are being added per year. Roads are already jammed. When you go slow like this, you emit more because the fossil fuel burning is very inefficient. So, you have to look at the fuel economy standards, miles per gallon. So, some countries are better than others. US, which builds big cars and does not mind burning, is sitting here at fairly low emission standards. And within US though, California has always stayed ahead and tried to catch up, but still quite far. China is doing better for starters. India is not here, but hopefully we will keep up our emission standards to deal with the traffic problems, in addition to trying to solve the traffic problems. So, I will not dwell too much on this, but this is the estimated potential for cutting CO2 by managing croplands, grazing land management, restoring cultivated organic soils, rice paddy management, livestock management and so on. So, if as a teacher you want to start something as a part of the course, you can either start collecting data and see locally where there is potential for reducing greenhouse gas, or you can at least begin to document where there are high emissions in your neighborhood. So, that is kind of a good addition to the course. So, in going from the impacts of climate change, we are now slowly thinking where the solutions might come from by looking at where there are emissions that are somewhat unnecessary. So, I want to get closer to the end by reminding ourselves again that when we looked at the temperature change from the beginning of the industrial revolution to the present, we said the temperature does not rise monotonically like carbon dioxide does. It has internal variability which makes it go up and down, and there are times when it might become slower, the so called global warming pause. But what we should keep in mind is that if you look at the decadal average temperatures have continued to rise. So, each decade is getting warmer than the previous one. So, we need not really get confused about the natural variability and the slowing and speeding up of the global warming because of internal variability like El Nino and so on. We should keep our eye on other factors like this, and also factors where it is getting warmer faster and why, and also remember that there are dynamic reasons like meridional overturning circulation which may slow down locally, but also keep an eye on how the precipitation is changing, especially the extreme events. So, to kind of come to conclusions, human fingerprints are now all over the place. So, we looked at multiple things, and you can always raise a doubt about whether this is cleanly attributable to human impacts or not, and whether that slowdown of warming is that means that global warming is not happening. So, there are all kind of confusing comments made by people, but if you take all the evidence together, this is a nice website I would recommend, which answers most of the questions raised by people who have confusing comments or wrong comments, or if you have questions about something you do not understand, like how the radiation balance works and so on. It is a tremendous resource. Okay. So, obviously, we are increasing fossil fuel. This is very precise, very accurate, no doubt at all. Other than that, everything gets complicated, but we can track the radiation change, even though, as I said, we say less heat escaping to space. We need to be aware that there are dynamic adjustments. So, the equilibrium is there, but it is happening at a different temperature. Cooling of the upper atmosphere, which is an evidence of lower troposphere heating up, allowing less energy to go into the stratosphere, and that then cooling the upper stratosphere. Again, I am simplifying. There are details of radiation physics that we have not really gotten into. It gets quite complicated, but if you remember that the cooling of the upper atmosphere is related to global warming, then you are doing well. Winters are warming faster than the summer. There is less oxygen in the air because the fossil fuel burning is taking up the oxygen. Nothing to worry about, but it is evidence of fossil fuel burning. And there is more fossil fuel carbon in the corals. We looked at delta C13, remember C12, C13, and how it changes in the air because of fossil fuel burning, how that is captured in corals. That evidence is very clear. Patterns of ocean warming, fossil fuel carbon also is found in the trees. Nights are warming faster than the days, which is because of the change in outgoing long wave radiation at night. So, clouds which can reflect light during the day can trap the outgoing long wave during the night, and there is no energy to reflect from the sun. So, these are kind of the fingerprints of human activity. Of course, there is increased humidity, there is increased precipitation extremes and so on, which are much more indirect. So, it is not just that climate scientists are looking at one piece of evidence, they are collecting many different pieces of evidence to say this is what fossil fuel burning and increased greenhouse gases are doing to our climate system. Long chapter, important chapter, you must be aware of all aspects of it and then choose how much to include and which parts to emphasize and so on. The more you know, the more better you will be at choosing and explaining. So, the modern climate change must be placed in the context of deglacial temperature and sea level changes as continents are moving, ocean is moving, and relative sea levels change slower and faster. And you also have to keep in mind natural variability or internal variability like El Nino, Pacific Decadal Oscillation, North Atlantic Oscillation. Radiative forcing due to greenhouse gases and land use change are now well measured. We have a good handle on it, and they are definitely emerging beyond the natural range, especially over the last 1200 years. Okay, that is something very concrete now. Global change is now manifest in the atmosphere, ocean, land, hydrosphere, cryosphere, and the ecosphere. We looked at examples, but there are literally thousands of other examples. I just picked specific ones, and the best report to focus on for that is the IPCC executive summary of the assessment report 5, which will be provided to you. It's only about 170 pages or so with lots of figures, lots of technical details there, but you should just kind of try to read it and capture the main points, because even climate scientists don't know all aspects of global warming. We cannot, because either we will be experts in one component or the other, and I can explain all the things that are there, but does not mean I know all the technical details that go in there. Okay? So, just familiarize yourself at least with the terminologies and so on. Models have shown great skill in reproducing the 20th century warming and reproducing things like medieval warming and little ice age, which gives us confidence that they will do the projections reliably. But there are lots of issues there, and we will get into that in the next section. Modulation of natural variability by global warming is not well understood. What do we mean? We said El Niños happen every 2 to 7 years, and there are some decades where there are more, some decades where there are less, and we said more recently there was a lot of warming near the date line compared to the coast of South America. So, did the El Niño change? So, how is global warming going to change natural modes like the monsoon and El Niño and Pacific Decadal Oscillation, North Atlantic Oscillation? We do not have a very good handle on it, and the models are not very skillful in doing that, because different models say slightly different things. So, we have to be careful about that, because they will have a feedback to global warming as well. The efforts to reduce carbon emissions are already underway. We will see that more in terms of renewable energies, but more specifically terminologies like mitigation and adaptation. We will get into the details of that. That is a good news. So, even if people do not agree, all countries are essentially involved in negotiating together what we should do about climate change. Doesn't mean everybody is doing something, but everybody is at the table saying they are worried about it. Cascading impacts via food, water, energy and health systems must be. So, I did not use this phrase before, but there are many figures that you can look up which show you what food, energy and water nexus means. So, you can just Google that and see that when climate changes, it affects agriculture, which affects water usage, which then affects how much water is available for energy, or energy is being produced that decides how much water is available for agriculture and so on. Altogether, they also affect human health, because food quality, air quality, water quality are all affected, and they all affect human health. So, we will come back and start with future climate change, which is a very vast topic again. So, we will take our time and have several lectures. See you next time.